Okay, the first part of this question is just your standard method for putting something of this kind in the form r sine theta plus alpha, and they're very kind. They tell you that alpha is an acute angle between 0 and 90 degrees. So you just need to find r using Pythagoras and alpha by doing an inverse tan the right way round, and use trial and error if necessary, but make sure you've got the right value by checking, by putting a value in for theta. In 782, one of the standard follow-ups, we're now solving something very similar to what we've dealt with there, equals 7. So you're going to have your r sine of theta plus alpha equaling 7. But theta's changed. We've now got 2x where theta was. So you know r, you know alpha, you want the answer to be 7, and you can start, in fact it's a good idea to start by getting values for theta. So theta equals various values, but of course theta equals 2x, so you're going to get various values for 2x, and you need to get all the right values. They're going to be more than 2, and that's because x can be in the range 0 to 360 degrees, so therefore 2x, or theta, is going to be between 0 degrees and not 360 degrees because we've doubled. So we need to get all the 2x values, all the theta values, between 0 and that increased limit, and then to get the x values we're going to take all 4 of these and divide them by 2. So make sure you do get all 4 answers rather than just 2 of the 4. Then in B1 we've got to prove an identity. We've got sine 2x, we've got cos 2x, we've got just tan of a single x. So this is unrelated really to part A. Here we're in the world of double angle formulae. Now there's only one formula for sine 2x. So starting with the left hand side, you're going to have your expression for sine 2x on the top. And then you're going to have 1 minus, and in brackets you want an expression with cos 2x. And there you've got a choice of 3. If you use the wrong one, then you can use the identity that links cos squared theta and sine squared theta. But you're probably best off trying to use the one that you can see will cancel out this 1. So if you use the version of cos 2x that starts with 1 minus, the logic for that is that 1 minus 1 is nothing, and so you'll end up with the 1's cancelling, minus times a minus is a plus, you'll have an expression for your sine 2x, and you'll have whatever comes in that correct identity for cos 2x, and you should be able to work with that until you get the answer, which is going to be 1 over tan x. And what's quite likely, given you're working with sines and coses in here, is that before you get to 1 over tan x, you'll get the reciprocal of tan x involving sines and coses, so it will be cos x over sine x at that stage, after you've simplified all of this. Hope that helps. However, here's a big fat re-entry point. You don't have to have done b.e1 or any of part A to be able to do b.e2. Hence means use what we've just done to solve this equation. And of course this thing we now know, I'm not going to use any of that, we know it equals 1 over tan x. So we're solving 1 over tan x equals tan x. And this is just some easy algebra to get started. You're going to get 1 equals, you're going to multiply both sides by tan x to get 1 equals something. And that's going to lead fairly directly to what tan x is. But there are 2 answers for tan x. This is going to be a squared. When you square root, don't forget there are going to be 2 answers for tan x. So once again, you're going to get 4 answers in the range 0 to 360 degrees. But solving this and getting 4 answers, really that is core 2 work rather than core 4.